All right, so 7.2, so there we go, right? The law of cosines. Hopefully you got that perfectly done on a quiz paper. So I think that now it's kind of easy to look at the patterns, right, and see how you're going to get those letters in the right place. All right, moving on to the second scenario that we can play with the law of cosines when it comes to solving for triangles. So this is called SSS. So it's a very unique setup for a triangle where all three sides are given. Okay. So that means all we have to do is to find out angles. Now, what do you think? Well, which one you think will be better when it comes to finding angles? The law of sine or law of cosine? Provided you have everything you need to use either law. Okay, Donovan, you said law of cosine. Why is that? Right? Right, good. So the law of sine requires an angle, right? So you don't have any angles, so you're dead end, right? So in this case, it's not which one is better. In the case of SSS, you will have to use law of cosine, right? But let me ask you again. What if you know one of the angles? Would you use law of sine or law of cosine? Raise your hand if you're a big fan of law of sine. Well, provided one angle. You're going to use law of sine to find out the remaining angles. Raise your hand right now. I thought you guys are a big fan of law of sine. It depends. Okay, well, that I'll take that as a good answer. You know, it really depends, right? But what about the rest of the class? Like, given one angle, would you guys prefer to use the law of cosines, the rest of the class? Because I saw, you know, McQueen and maybe Donovan, right? Raise their hands just now. Okay. You know, what's good is you're not blindly saying that, Dr. Wang, I'm just go with law of sine, no matter what. You know, because if you have an angle, right, you can do it. Law of cosine, yeah, it doesn't matter whether you have, you know, those sides or not, right? I'm going to try to figure it out. Now, all I have to say is law of cosine has its own benefit when it comes to finding the angles because it does not have ambiguity. If you invert the cosine, you're going to get the angle correctly, right? So now let's try that. At least with the SSS, you'll see it. So we're given. Well, you know what? Let's not spoil ourselves, you know, at this time, even with the diagram, right? But I was asking the student in the morning to draw the triangle, right? But now you see that we have all three sides. What we're looking for are angles A, B, and C. So let's say we want to find out the angle A. So I know that I need to start with A squared, right? And I have B squared plus C squared minus 2BC cosine A. Now, if you want, you can start plugging numbers, right? But I'll say that you may or may not realize some professors don't write the law of cosine this way. Or they might just write it, you know, in both ways. This is one of the ways, right? But you guys know this is equivalent to cosine A, which is equal to, let's see, B squared plus C squared minus A squared over 2BC. You guys see that? Like if I isolate the cosine A, so I can either throw this guy to the left-hand side, subtract that A squared, give out of the coefficient, this is what you end up getting. But look at a pattern. How easy it is to either remember this form or that form. Because A is still corresponding to that A all the way to the other side, right? And you have two other sides. You take the sum of the squares of them, divided by 2 times the product of the two sides. So now you're ready, right? Just have to plug in, you know, the numbers. So B is 10. So 10 squared plus c is 5, I square, minus a will be 8 square, divided by 2 b times c, right? So it'll be 10, 2 times 10 times 5, right? I mean, you work this out, right? Whatever that is, and find out, oops, what the, well, you know what, let's get that, you know, in case. Yeah, how much is this ratio? Right, 10 square plus 5 square minus 8 square. Right, so divided by, is that 100? So it'll be 0.80, 0.61. Right, so then the angle A will be inverse cosine of 0.61. Now, if you're in radian mode, so if you're in degree mode, right, you're gonna get, let me see if I do have it here. Well, I don't see the inverse for some reason. Maybe I was, but invert it. That's most scientific. All right, so we'll do inverse cosine, right, 0.61, 0.61. So about 52, right, 0.4. Let's go with 52, you know, it's close enough. 52, oops, degree, right? And you're done with angle A, right? There's no other angle that can ever work out. It has to be 52. So now you might say, hey, I have an angle. I have all the 3 sides. Can I just do the law of sines to get the other angles? You could, right? But remember that, you know, if you're ever going to get an angle from the inverse sine, you're going to have to think about its complementary. As you can see that this angle is fairly small. I mean, not too small, but it's possible they have, you know, ambiguity. So what if, let's do another round of the same exact calculation, but let's get the angle B. How about that? I'm going to start with cosine B. Can you guys get me the right-hand side of this equation based on the original form that you remember for the law of cosine? It will be a fraction, right? What goes to the top? I want cosine B by itself on the left. AC, a squared plus c squared minus b squared, yeah, b and a b, right? Divided by 2 times AC. There you go, right? How easy is that? Well, plug in numbers, right? Well, I'm not going to do it, right? So you get that, and invert the b, invert the cosine, and you will get a unique angle. Exactly, right? So, I mean, I don't think this is bad at all, you know, compared to the law of sine. Therefore, I'm glad that people are saying that it depends. You know, you're open to both law of sine and cosines, right? You might have a strong preference towards one of them. You know, you're not wrong, but please understand that you're better off sometimes with law of cosine. And in this case, SSS, definitely give it a try. Law of cosine. Okay, not even SSS. What was the previous case? SAS, right? You have 2 sides and an angle in between. Again, try the law of cosine. But you know that if somehow you're stuck, then, you know, try law of sines. You know, definitely 2 of them will save you in whatever triangles you're dealing with. All right, so I guess that you guys are okay with it. Now in this case, it's a word problem, right? So I feel like that, you know, I'll just draw the diagram for you to figure it out if you want, right? Because you're gonna have to do that, you know, for the quiz anyway. But let's make sure that we read it properly. So the 2 airplanes leave a airport. That means the same airport, right? They have the same starting point, but they are going in 2 different directions. One going directly north, right, at a speed of 400 miles per hour, and the other one has a bearing. All right, so now let's say this is Oops, let's see. This is the origin, right? With both planes start. This is east, north, right? Let's see. Okay, that's all I need. A plane head directly to the north. Let's say that's let's call it A, right? Another plane, right, going this way, not this way, a bearing. So north, 75 east. Okay, north, turn to the east, right, by 75 degree. It'll be somewhere along this line, right? So this angle is 75 degree, right? And let's call that plane B. All right, so now what they want is how far apart will the two airplanes be after 2 hours. So let's say after 2 hours, they're getting to the two locations you see on the screen, right? So one plane is at point A, the other plane is at point B. How long is AB? A plus, no, triangles don't do that. Yeah, numbers, they do work out like that. So I have a triangle with an angle 75 degree given, but have no sides at all, right? So we'll ask yourself, how much is AO? We know that? What is it? Okay, 800 miles, not 400 miles per hour, right? Because exactly, that's the speed, and you have to multiply with the time to get actually how far it traveled. Good. So this is the, I guess, the only catch for a problem like this. So 400 times 2 gets you 800 miles, right? Then OB, oops, BO. Oh, come on. BO is 350 times 2. That'll be 700, right? So now you have it, right? So this guy is 800. This guy is 700. Again, things are not drawn to scale, right? Looks OB is longer, but it's not. Okay, so what would you do to find AB? Law of sine, law of cosine. You have OA, OB given. You have the angle in between the two sides. Looking for the opposite side of the angle that was given. This is called SAS. That's one of the cases I said that you better try the law of cosine, right? So now, let's see if you guys can write down the law of cosine, not in terms of those little a, b, c, right? So how about, I'll just put, let me put down AB, that's what I'm looking for, right? And it's getting squared. Equals to the other two sides, right? So AO square plus BO square minus 2 times AO, BO times cosine of the angle AOB, right? We have everything, right? So you should figure it out. Of course, make sure you take a square root, right? Taking the square root. Say it again. Why is it not AB? Or the angle has to be the angle over here, and the way you call it is AOB, right? Or you can call it angle O, so people's gonna see it. Well, you know what? You're better off just putting 75 degree. You don't have to call it like any kind of a fancy way, right? Just, you know what? This is probably the only thing you're gonna write down to let me know you are finding the AB, right? Square it. AO, don't put down AO. You just put 800, right? Square it. Plus 700 square minus 2 times 700 times 800 times cosine 75 degree, right? So I'm not gonna embarrass you with the work. AB will be some kind of decimals, right? In miles. All right. Now the last thing on the 7.2 is another fancy formula, and see how much you're gonna like it. They call it Heron's formula. And what's that for? It's for finding the area of a triangle, right? Any triangle, provided 3 sides, no angles. All right, so it turns out that for a triangle with 3 given sides, if they do make a triangle, that triangle is unique. There's not going to be any ambiguity going on. And see how interesting the formula is? It's a square root. So right off the bat, it's telling you that the number's not going to work out, most likely, but it will sometimes. So, you know, A, B, C are the 3 sides, whatever they are. So if you wonder what is S, S is half perimeter. So you're going to add up A, B, C, take a half, right? So that's all you have to do, right? S times S minus A times S minus B times S minus C. And that's all, right? So it's just another formula, right? So now, technically speaking, you know at least 3 different versions of the triangular area formula, right? The 1/2 base times height, the 1/2 AB sine C, right? And now the Heron's formula.